Okay, so the next question that we have here is question number 6, which is you want to find the derivative of this function. And the function is basically, if I take the function as f of x, I can write it as x raised to the power n plus a times x raised to the power n minus 1 plus a squared times x raised to the power n minus 2 plus all the way up to a raised to the power n minus 1 times x plus a raised to the power n. So to take the derivative of this, we can call it you can call it a polynomial, of course. So to take the derivative of this, you can use for example, the product rule. And the product rule, we said that if you have basically two functions, f of x and g of x, let's say that you have two functions, f of x and g of x, and they are multiplied together, and you write d by dx of f of x times g of x, the derivative of these two functions multiplied together is always equal to basically the derivative of the first function, which is d by dx of f of x, times the second function, which is g of x, plus the first function, which is g of x, times the derivative of the first function. I'm sorry, the first function, f of x, times the derivative of d by dx of g of x. And then we said that if you take basically f of x as u, for example, and if you take g of x as v, then you can write u times v whole prime is equal to u prime times v plus u times v prime. So you can use the product rule, and this was called the product rule. You can use this product rule in order to, and of course one more thing that we said in the algebra of derivatives was that we said that if you have the d by dx of f of x plus g of x, that is equal to d by dx of f of x plus d by dx of g of x. That means that if you have basically this function, which is f of x, g of x, h of x, I of x, and so on and so forth, then the derivative of the whole function is going to be the sum of the derivatives of each of the terms basically added together. So then based on these three, you can write. So over here, for example, you can see that the derivative of, for example, x raised to the power n, that is just one function, not multiplied by anything. So you know that d by dx of x raised to the power n is equal to n times x raised to the power n minus 1. We had this as a theorem. Now if you have d by dx of a times x raised to the power n minus 1, that is equal to basically, we said basically the derivative of the first function, which is 0, it's a constant function, 0 times x raised to the power n minus 1 plus the first function a times the derivative of the second function, which is n minus 1 times x raised to the power n minus 2. which is equal to a times n minus 1 times x raised to the power n minus 2. Now, if you have the derivative of, for example, let's say that you have the d by dx of a squared into x raised to the power n minus 2, that is equal to, again, the derivative of the first function 0 times the second function x n minus 2 plus the first function x raised to the power, plus the first function, which is a raised to the power 2 times the derivative of the second function, which is n minus 2 times x raised to the power n minus 3. And so you can just keep going and the same thing will happen. And then when you get to basically the derivative of this last term, it's a constant function, it's going to be equal to 0. The derivative of this term over here is going to be d by dx of a raised to the power n minus 1 times x, which is equal to basically the derivative of the first function, which is equal to 0 times x plus the first function times the derivative of the second function, which is equal to just simply a raised to the power n minus 1. And right over here before this term, you have another term, which is, you see over here, you have a raised to the power 2, a raised to the power n minus, or from here you have a raised to the power n, a raised to the power n minus 1. So this would be a raised to the power n minus 2. And over here you have x raised to the power 0, x raised to the power 1, x raised to the power 2. So this term would be a raised to the power n minus 2 times x raised to the power 2, and the derivative of that would be the derivative of the first function 0 times x squared plus the first function a raised to the power n minus 2 times the derivative of the second function, which is 2x. So I can write this as 2 times a raised to the power n minus 2 times x. So then the derivative of f of x, d by dx of f of x, is equal to, well, the derivative of this first one, which is n raised to the power n times x raised to the power n minus 1, and then you have the derivative of a times x raised to the power n minus 1, which is this thing over here, a times n minus 1 times x raised to the power n minus 2, x raised to, so the derivative of this second function, a times x raised to the power n minus 1, is basically a times n minus 1 times x raised to the power n minus 2. This third function, a squared times x raised to the power n minus 2, is basically, you can write this as, based on these terms over here, you can write it as a squared times n minus 2 times x raised to the power n minus 3. So I can write it as plus a squared times n minus 2 times x raised to the power n minus 3. And the derivative of this function over here, a raised to the power n minus 2 times x squared, is equal to basically a raised to the power n minus 2 times 2 times x times 2 times x, and the derivative of this last function over here, a raised to the power n minus 1 times x, is equal to plus a raised to the power n minus 1. So, and of course there is this, you have basically over here you have plus, meaning that there are all of these terms in between that go between these all of these terms. So then the derivative of the whole function is basically this expression or this function over here, which is n times x raised to the power n minus 1 plus a times n minus 1 times x raised to the power n minus 2 plus a squared times n minus 2 times x raised to the power minus 3, all the way up to a raised to the power n minus 1. So now that was number 6. Now number 7, you have for some constants a and b, find the derivative of these functions. So suppose that you have x minus a into x minus b. Suppose that you have f of x is equal to x minus a times x minus b. So you have two functions multiplied together. You can use the product rule in order to find the derivative of these two functions. So we said that u times v whole prime is equal to u prime times v plus u times v prime. So you can use this over here in order to find the derivative of your function. So that means that then basically f prime of x, which is basically d by dx of f of x, is equal to the derivative of this function times the derivative of this function times this function. So the derivative of this function d by dx of x minus a is equal to basically d by dx of x minus d by dx of a minus d by dx of a, and that is equal to 1 minus a. I'm sorry, 1 minus 0. d by dx of a is equal to 0. So that's 1 minus 0, which is equal to 1. So this is equal to 1. Now if you have the derivative of the second function, d by dx of x minus b, it's again the same story. It's basically the derivative of the first function, which is 1, minus the derivative of the second function, which is 0. This is again equal to 1. So now here you can write d by dx of f of x, which is basically this function over here, is u prime times v, which is u prime is the derivative of the first function, which is 1, times v, which is x minus b. So 1 times x minus v is x minus b, plus u times v prime, so x minus a times 1, which is basically that, and then you have x plus x minus a minus b, which is equal to 2x minus a plus b, for example. Or you can also say 2x minus a minus b. So the second part of this question is you want to find, for example, the derivative of ax squared plus b. Let's say your f of x is equal to ax squared plus b all squared. Okay, so about this function, you know that basically if you have the basically we said that d by dx of x raised to the power n is equal to n times x raised to the power n minus 1. But then the problem here is that you cannot treat this as x, because you have all kinds of things over here. Okay, so what you need to do here is you need to basically expand this. There seems to be no other way. You might be able to find some sort of formula for this, but at this point what we can do is that we can write this as basically this is the same thing as a plus b raised to the power 2, which is equal to a squared plus 2 times ab plus b squared. So I can write this as a squared x raised to the power 4, and I need to write my 4's better than that. So a squared x raised to the power 4 plus 2 times ab x raised to the power 2 plus b raised to the power 2. So that is your function. Now this is this is your f of x. Now d by dx of f of x is equal to d by dx of a squared x raised to the power 4 plus 2 times ab x raised to the power 2 plus b squared, which is equal to d by dx of a squared x raised to the power 4 plus d by dx of 2 times a times b, 2 times a times b times x squared and then times plus d by dx of b squared. Now this is again the same thing as u times v whole prime, which is equal to u prime times v plus u v prime. And so you can write this as basically, let me write this step by step and then we will add them back together. So let's say that you have d by dx of a squared times x raised to the power 4. That is equal to u prime, which is 0, times x raised to the power 4 plus u a squared times v prime, which is 4 times x raised to the power 3. So this is equal to 4 times 4a squared x cubed. This is 4a squared x cubed. So you can write this as 4a squared x cubed. The next thing that we have is basically the derivative of 2 times ab times x squared, which is equal to, basically again you can take this whole 2 times ab as your constant and as your first function, which is just nothing but a constant, and the second part is basically another function. So you can think of this as basically, you can think of this as 2 times ab times x squared, and you want to take the derivative of this function, and you can think of this as your u, and you can think of this as your v. So then basically you have u prime, which is 0 times x squared, plus u, which is 2ab times v squared, which is basically 2x, which is equal to basically 4ab times x, 4 times ab times x. Times ab times x. Now the third part over here is the d by dx of b squared, which is just equal to 0. So so that's the derivative of your function. So this is part 2 of this question, number 7, 4ax. So you can write this as 4 times ax times x squared plus b. Ax squared plus b. Now the next part of this question is f of x is equal to x minus a over x minus b. Okay, so you can think of this as basically two functions. We said that if you have u by v whole prime, it is equal to u prime u prime times v, u prime times v minus uv prime over v squared. So then f prime of x would be equal to basically u prime. So u prime, if I take this as u, then d by dx of x minus a is equal to d by dx of x minus d by dx of a. Now d by dx of x is equal to 1, d by dx of a is equal to 0, so this is equal to 1. And then d by dx of x minus b is equal to d by dx of x minus d by dx of b. which is equal to 1 minus 0, again equal to 1. So then you can write this as u prime is 1 times v, which is x minus b, minus u times v prime. V prime is equal to 1, so u is equal to x minus a over v squared, which is x minus b whole squared. So this is equal to x minus b minus x plus a over x minus b whole squared, which is equal to, you can cancel these two out and you can write this as a minus b over x minus b whole squared. This is f prime, this is f prime of x. Now question number 8 is find the derivative of x raised to the power n minus a raised to the power n over x minus a for some constant a. And as you can see, basically all of these derivatives that we are calculating, these are all useful derivatives, meaning that you can write them as some general form of derivatives and use them over and over again, because they will come up, you will basically need them. So I think I'm going to do the same as well. So if you have the derivative of x raised to the power n, for example, let's say your f of x is equal to x raised to the power n minus a raised to the power n over x minus a. I think we had something like this. There was a limit that we had, that which was basically the limit of x raised to the power n minus a raised to the power n over x minus a as x tends to a is equal to something like, I don't remember that, but we had this limit actually. Okay, so the derivative of this function, let's see how we can find the derivative of this function. So we said that basically you can find the derivative of this function if you have, for example, something like u divided by v whole prime is equal to u prime times v prime, u prime times v, u prime times v minus u v prime over v squared. U prime times u minus u v prime over v squared. So this becomes your u, this becomes your v. So then basically f prime of x would be equal to u prime times v. So u prime, which is basically the derivative of this function, if you have d by dx of x raised to the power n minus a raised to the power n, this is equal to d by dx of x raised to the power n minus d by dx of a raised to the power n, and this is n raised to the power x minus n raised to the power n times x raised to the power n minus 1. And d by dx of a raised to the power n is equal to 0. So that's n times x raised to the power n minus 1. So d by dx of this function is equal to n times x raised to the power n minus 1. Now v prime over here, which is basically the derivative of this denominator, d by dx of x minus a is equal to d by dx of x minus d by dx of a, which is equal to 1. So then u prime is equal to, this is equal to u prime, and this is equal to v prime. So then u prime is equal to n times x raised to the power n minus 1 times v, which is times x minus a, minus u times x raised to the power n minus a raised to the power n times v prime. V prime is equal to 1 over v squared, which is equal to x minus a whole squared. And so you have basically you have n times x raised to the power n. If you multiply these two together, you get n times x raised to the power n minus a n x raised to the power n minus 1 minus x raised to the power n plus a raised to the power n over x minus a raised to the power 2. So of course you can simplify this a little bit, but I suppose, so this is n times x raised to the power n minus a n x raised to the power n minus 1 minus x raised to the power n plus a raised to the power n over x minus a raised to the power 2. This is the derivative of your function. So question number 9 is you want to find the derivative of these 6 functions. Of these 6 functions over here. So you have, for example, suppose that your f of x is equal to 2x minus 3/4. So f prime of x would be equal to basically d by dx of 2x minus d by dx of 3/4. Now d by dx of 2x is d by dx of 3/4 is equal to 0. That you already know. But d by dx of 2x is basically u times v whole prime is equal to u prime times v plus u times v prime plus u times v prime. So in the case of this function, for example, d by dx of 2x, that's going to be equal to u prime times v. So u prime is basically the derivative of 2, which is 0. 0 times x plus u times v prime. So u times 2 times 1. So this is equal to 2. And of course it makes sense because it's just a straight line having the slope 2. So the slope of the line is basically the derivative of the function, and that is equal to 2. So this is equal to 2. Or suppose that you have, for example, let me take my answer over here, number 9 and 2. Or suppose that you have, for example, 5x cubed. Suppose that your f of x is equal to 5x cubed plus 3x minus 1 plus 3x minus 1 times x minus 1 times x minus 1. So you can treat this as basically two functions multiplied together, or you can actually multiply them together before. I think multiplying them would be easier, because that way you would have to find the derivative of the first function and then the derivative of that, and then you would have to multiply twice. So if you multiply once in the beginning, that would be much better. So you can write your f of x as basically 5x raised to the power 4 plus 3x squared minus x minus 5x cubed minus 3x plus 1 which is equal to 5x raised to the power 4 minus 5x cubed and plus 3 times x squared minus 3x minus x is minus 4x plus 1 and now you can find the derivative of this function, meaning that you can write d by dx of f of x is equal to d by dx of each one of these terms, which is basically d by dx of 5x raised to the power 4 minus d by dx of 5x cubed plus d by dx of 3x squared minus d by dx of 4x plus d by dx of 1. And of course you can basically, we said that d by dx of x raised to the power n is equal to n times x raised to the power n minus 1. And let's work out some routine for this kind of these kinds of functions. For example, if you have d by dx of 5x raised to the power 4, what you will get is basically, if I take this as u and if I take this as v, then over here I would have u prime times v plus u times v prime. So then u prime is always basically 0, because this is a constant function, so this term goes to 0. And then you have u times v prime, so that means that then you will get basically only u times v prime. U times v prime is basically this constant function times the derivative of this function, meaning that if you have, for example, d by dx of some a times x raised to the power n, that's going to be equal to the derivative of this function would be n times x raised to the power n minus 1, and then you multiply a by that, that's a n x times n raised to the power n minus 1. So we can use this from now, and you can use this without using the product rule, because one of the terms actually always goes to 0. Okay, so now d by dx of 5x raised to the power 4 is basically 5 times 4x cubed 4x cubed, which is equal to 20x raised to the power 20x cubed. 20x cubed. Or 5 times x cubed would be basically 15 times x squared. 15 times x squared. Or 3 times x squared would be 6 times x, would be 6x. And 4x would be just 4, because that would be 4 times basically x raised to the power 0, so that would be 4 times, that would be just 4 plus 0, which is equal to 20x cubed minus 15 times x squared plus 6x minus 4, and that is the derivative of your function, the first one. No, I'm sorry, the second one, number 9, question part number 2. 20x cubed minus 15x squared plus 6x minus 4. Okay, so the next example I had to re-record and re-record and re-record. So, but the next question that we have here is the function over here, which is x raised to the power negative 3, I suppose. Suppose that your function is f of x is equal to x raised to the power negative 3 times 5 plus 3x. So you can do this in different ways. For example, what you can do is you can write this as, for example, f of x you can write it as f of x is equal to 5 times x raised to the power negative 3 plus 3 times x raised to the power negative 2, and then, for example, d by dx of f of x will become basically d by dx of 5x raised to the power negative 3 plus d by dx of 3x raised to the power negative 2. So you can do this, and then this would be, for example, negative 15x raised to the power negative 4 plus negative 6x raised to the power negative 3, and that's the same thing as, for example, negative 15 over x raised to the power 4 minus 6 over x raised to the power 3, and then, for example, you can take a negative 3 over x raised to the power 4 out, and then write this as basically 15 divided by 3 is equal to 5, and then negative divided by negative is positive, 6 divided by 3 is equal to 2, and x raised to the power 3 over x raised to the power 4 is equal to 1 over x raised to the power 4 is equal to basically 1 over x raised to the power 3 divided by 1 over x raised to the power 4, which is equal to 1 over x raised to the power 3 times x raised to the power 4, which is equal to x. So that would be, for example, the derivative of your function. And alternatively, what you can do, if you don't want to multiply, what you can do is that you can write this as f of x as basically x raised to the power negative 3 times 5 plus 3x, and then you can write this as, you can use the product rule, u times v, the Leibniz product rule. U times v whole prime is equal to u prime times v plus uv prime, and that would be equal to basically the derivative of the first function. So then f prime of x would be equal to -3 times x raised to the power -4 times 5 plus 3x plus u times x raised to the power -3 times the derivative of the second function, which is equal to 3. And that is equal to -15 x raised to the power -4, -9 x raised to the power -3 plus 3 times x raised to the power -3, which is equal to -15 x raised to the power -4. -4 plus 3, -9 plus 3 is equal to -6 x raised to the power -3. And then you can write this as -15 over x raised to the power 4 minus 6 over x raised to the power 3, and then again you can take a -3 over x raised to the power 4 out and write this as 5, for example, plus 2 over x, for example. Or I'm sorry, not 2x, because that's -6, and then over here you will get x raised to the power 3. So that's basically this example. Of course, in the beginning you will get all of these wrong, so you need to be patient with yourself and just do it over and over again until you get it right, and then after a while you will learn basically the algebra of derivatives and these two rules, which are basically u times v whole prime is equal to this, and u by v whole prime is equal to, for example, this rule over here, which is u prime times v minus uv prime, for example, over v squared. Basically you need to learn these two rules, and then there are a few more things that you need to learn in the process, and then that's basically differentiation. Okay, well, suppose you have, for example, x raised to the power 5. Suppose that your f of x is equal to x raised to the power 5 times 3 minus 6x raised to the power -9. 3 minus 6x raised to the power -6, x raised to the power -9. You can again use the product rule, meaning uv whole prime is equal to u prime u prime times v plus uv prime. And so, for example, f prime of x, which is d by dx of f of x, is equal to basically 5x raised to the power 4. It's the differentiation of x raised to the power 5 times 3 minus 6x raised to the power -9 plus u times x raised to the power 5 times the differentiation of this function, which is negative, actually it would be negative 3 minus 6x raised to the power -9. This is nothing but, if you want to calculate the d by dx of this function, that's basically d by dx of -3 minus d by dx of 6x raised to the power -9. So this is equal to 0. This is equal to 0. So then d by dx of basically 6x raised to the power -9 is negative 54x raised to the power -10, and you have a negative sign over here, so this becomes positive. So that's 54 x raised to the power negative 10. And then this is equal to 15 x raised to the power 4 minus 30 x raised to the power negative 5. And here you have 54 x raised to the power negative 5, which is equal to 15 x raised to the power 4, basically positive 24 x raised to the power negative 5. And you can divide by 3 here. 24 is the same thing as 2 times 12, 2 times 6, 2 times 3. So, and 15 is 3 times 5, so you can take it 3 out here. You can take it 3 out here, 3x raised to the power take it 3 out here, and you need to take some power of x out, and x raised to the power 4. If I take x, so if I rewrite this, let me rewrite this over here. So I have 15 x raised to the power 4 plus 24 over x raised to the power 5. So if I take x raised to the power 4 out, for example, I don't know, I can take anything out really. It just depends on what you want to do. But basically the final answer has been written like this, so I'm not going to bother about the rest of that. Okay, so the next part of this question is, for example, some similar question, which is, for example, your f of x is equal to x raised to the power negative 4 times 3 minus 4 x raised to the power negative 5. Okay, so again, uv whole prime is equal to u prime times v plus uv prime. So f prime of x is equal to the differentiation, or the derivative of this, which is equal to negative 4x raised to the power negative 5 times this function, which is 3 minus 4x raised to the power negative 5, plus this function, which is x raised to the power negative 4 times basically the derivative of this function, d by dx of 3 minus 4x raised to the power negative 5, which is equal to, for example, d by dx of 3 minus d by dx of 4x raised to the power negative 5, which is equal to 0 minus, this is negative, minus negative 20x raised to the power negative 6, which is equal to 20x raised to the power negative 6. This is 20x raised to the power negative 6. Now, here you have negative 12x raised to the power negative 5 plus 16x raised to the power negative 10. And over here you have plus 20x raised to the power negative 10, which is equal to negative 12x raised to the power negative 5 plus 36 x raised to the power negative 10, which is equal to negative 12 over x raised to the power 5 plus 36 over x raised to the power negative 10. I'm sorry, positive 10. And then you can take, for example, a 12 out here and a x raised to the power 5 out, for example. Or you can take a x raised to the power 10 out. So I take for example, 12 over x raised to the power 10 out, and that becomes, for example, negative 1 times x raised to the power 5. So negative 12 plus 3 plus 3, right? And so that is equal to 12 over x raised to the power 10 times 3 minus x raised to the power 5, something like that. Part 5 of this question is negative 12 over x raised to the power 5 plus 36 over x raised to the power 10, which is basically, this is the final answer in the book.